Hello, this is Gareth from Creative Conners. In this short video, we're going to look at basic cue writing in Spikemark. I've got a show opened up here with three motors: a deck winch, an elevator, and a turntable. Before we write our first cue, I'd like to point out one of the new features in Spikemark. With the deck winch selected, I can scroll down through its properties until I get to the speed section. Here we can see the maximum speed value that we've set previously for 35 inches per second. The default speed and default acceleration values are new to Spikemark. When you add a motor's movement into a cue, it will default to using these two values for the speed and acceleration. You can certainly override these values on a cue-by-cue basis, but this gives you a nice starting point when you're writing your cues. Oftentimes in shows you'll have a speed value and an acceleration value that are pretty common throughout the show, and this will save you a little bit of time adjusting those parameters. So for this motor, I'm going to go ahead and enter in a default speed of 20 inches per second and a default acceleration of 10 inches per second. With the elevator, I'll give it a default speed of 12 inches per second and a default acceleration of 8 inches per second. For the turntable, maybe a default speed of 15 degrees per second with a default acceleration of 5 degrees per second. Okay, with those values set, let's write our first cue. To add a motor into the cue, simply click the Add Movement button in the cue grid. As you see, the deck winch has now been added to cue 1. The target position is 0. The speed has defaulted to 10. Acceleration to 10. And then we have a ramp time and total time values. Since we are currently sitting at 0 inches, the total time to complete this cue is only 0 seconds. For the first cue of the show, total time and ramp time are computed from the current position of the motor. In consecutive cues, we'll see how ramp time and total time remain constant regardless of the motor's current position. Let's say I want to add the elevator into this cue as well. This time, instead of pressing the Add Movement button immediately, I'm first going to jog the motor to a position that I want it to be in for the cue. I'm going to take the elevator, select forward, and just slowly run it up. And let's say that's a good spot. Now I press the Add Movement button. As you can see, the cue takes the current position of the motor and makes that the target position for the cue, and then uses our default acceleration and speed values to fill out the rest of the parameters. For the turntable, let's add the movement and now manually type in a value. We don't want this cue to be at 97 degrees. Instead, let's make it 360. So if I select the numbers in here and delete out the old value, I can type in 360. And for this cue, let's override the default parameters as well. For speed and acceleration, I've got 12 degrees per second for speed and 6 degrees per second for acceleration. Alright, that looks pretty good. Let's go ahead and load this cue and run it. As you can see, our stage model updates. Motors that are about to run are now shown in red, indicating that they've been loaded. If we zoom in, we can see here on the turntable that we have kind of a ghosted indicator that shows us where this turntable is going to rotate to. This is the current position of the turntable, and it will rotate around until we get back to 360. On the other two motors, you'll notice that we are currently sitting at target position by nature of how we wrote those cues. So these motors aren't going to move at all in this cue. We'll make them move somewhere for the next cue. In the cue grid, all motors indicate that they're loaded by having the little rocket icon with a countdown timer, showing that they're ready to go. So if I run this cue, we can see the deck winch and elevator completed immediately because they were already sitting at their targeted position. The turntable is currently running to position, you can see the indicator is moving around, and when it reaches the ghosted image, it will stop. Perfect. Alright, now let's write another queue. We right-click on the queue grid, select Add Queue. Let's make this queue 2.5. And we'll put a description in as second queue. Now maybe for this queue we don't want to have all of the motors in the queue. Perhaps this time we'll just take the deck winch and the elevator. Using the same technique I used in the previous queue, I'm going to grab the deck winch and manually jog it out into a position that I like. And then add the queue. And the elevator, this time I'm going to send it to a distinct numeric value of 0, just sending it all the way back down to the basement. So now if we run this queue, again we saw the deck winch completed immediately because it's currently sitting on its target value. And the elevator has returned to the basement. Let me add one more queue. We'll just make this queue 3. We'll call this one turntable only. I'm going to add the turntable to this queue. And we're going to send it back to 90 degrees. And maybe we'll make the acceleration a little faster so it gets up to speed quickly. Now here you can see, because my turntable was in Q1 at position 360, and in my new queue, the turntable is going to 90, Spikemark automatically calculates the total time and the ramp time that the turntable will take to get from Q1 to Q3. And this will remain constant even if I take the turntable and move its position now manually. So you can see that Spikemark is paying attention not to the current position of the motor, but to its last programmed position in the show. I could take total time. Instead of having it be 19 seconds, maybe I want it to be 22 seconds. And you can see now it has adjusted the speed and acceleration values to maintain a 1.5 second ramp and a total time of 22 seconds. Great. Let's go ahead and run this. Fantastic. Let's collapse all of our queues so we can see more queue grid information. When it's collapsed, we can see we still have the queue number, the total time the queue is going to take, the target position for each motor, and then the individual times of travel for each motor in the queues. I'm going to load up Q1, this time using the jump to queue feature on the queue controller. And now we can see everything should be moving in this queue. Our wagon should be moving back off stage, our turntable will be rotating back around, and the elevator should be coming up. Everything turns green and starts moving. Fantastic. As we're waiting for our turntable to finish up, let's go ahead and just start adding another cue. We'll call this maybe all on stage. I'm going to go ahead and add all of my motors in to this cue. I'll put the turntable to position 0, the elevator to position 120, and my winch wagon to position 200. Very nice. Now we can see here by looking at this cue that after Q3 finishes up, the turntable will be at position 90. It will then take 9 seconds to move to its Q4 position. The elevator will be at position 0 after it finishes up Q2.5, and then it's going to take 11.5 seconds to complete Q4. The deck winch will be at position roughly 116 inches after Q2.5, and it's now going to take 6.19 seconds to complete. Oftentimes in a show, you want all the motors to start and end at the same time. So here what I want to do is I'm going to take the total time for the cue, and I want to make it all happen in 10 seconds. You can see that Spikemark has now recalculated each motor to finish in a total time of 10 seconds. They've also got their individual ramp times, but the total time should finish in 10 seconds. So let's run through the cues. Q2.5. While this is running, I'm going to go ahead and pile on the turntable cue and let it run. Pile-on queuing is very useful in shows where you might need to run multiple cues at the same time, but you can't automate the links. Perhaps they're actor-driven, or they need to be handled by a call to the stage manager. In those instances, you can simply load up another cue while the first cue is running and run it. Great. Now everyone's in position. We'll load up Q4 and run it. And since these have all been programmed to complete at the same time, we should see that they click off in very close proximity to one another. Look at that. There was maybe a split-second difference between motor to motor, but they ended certainly well within tolerance of what we could call being a simultaneous end. So far, we've been looking at writing cues by entering in distinct position values into the target fields in the cues. One of the great new features of Spikemark is the use of something we call spikes. The idea here is very simple. It's much like putting a piece of spike tape down on the stage floor. You might have an on-stage spike, a parlor scene spike, an Act 3 preset spike, and so on. Traditionally, you would have a stagehand push a wagon out until the wagon rolls over the spike tape for that position. If, during the tech process, you find out that that spike needs to move on stage a couple of inches, you simply move the spike tape, and now the stagehand will push it on stage a couple more inches. In Spikemark, the idea is very similar. We're going to create software spikes, and then we can refer to them by name, and the values are checked every time the cue is run. So if we ever need to change a value, we can change it in one place, and it will be updated throughout the show. Let's see this in action to get a feel for how it works. I'm going to add a cue. Wagons off. Turntable to 90. So now let's add each motor back in. This time I'm going to select the spike button to pick a spike. We don't currently have any turntable spikes defined, so let's add one. And we'll call this halfway with a position of 180. We've now made the spike, and we just need to select it and press OK. Now you can see that the turntable, instead of having a position value displayed here, has the spike name, and the spike name is shown in the button as well. Let's do the same thing for the elevator. Let's add a new spike, call it down, add a value of 0, select the spike, and press OK. And we'll do the same thing for deck winch. We'll call it off stage, a position of 0, and press OK. Looking at our diagram in the stage model, we can see that we've added in these little thumbtack icons to each motor. Those represent the spikes. As we add more spikes, they'll appear in different spots of the track. Let's go ahead and run our cue. As you can see, everyone's running back to their positions. Great. Now let's write another cue. We'll call this one Wagons On. Turntable to 0. And actually, I'm just looking at this. I should correct my label here. We ended up using 180 degrees in the previous cue, not 90. That would confuse me if I was running the show. Alright, so let's add in our 3 motors again. And this time, we're going to create spikes again, but I'm going to jog a couple of these out and use their current positions to create the spikes. That looks good for turntable. Let's move the deck winch out to roughly center. That's pretty close. Great. So for the deck winch, again, we'll click our spike button. We're going to add a new spike. And you can see here that it's grabbed the current position of the motor and is using that for the spike position. We'll call this center. We'll select it and press OK. For the elevator, I'm going to add a new spike. We didn't jog this one into place because I want to type in the exact value here. 120. Great. And OK. We'll call this 3/4. Maybe we'll abbreviate that just so it doesn't take up a lot of room in our cue. 3/4. And we'll leave that value in place. Again, we have to remember to select the spike and then press OK. Let's go ahead and adjust our ramp times. We'll type in 3 and a total time of 10. Great. Now we've recalculated all of our speed and accelerations for each of the motors in this cue. That means that they'll all have the same ramp and they'll all have the same total time. Let's go ahead and run our cue. Now you can see our 2 of these motors completed immediately because of course we used their current positions as the spike position for this cue. And then our elevator has now driven up to spike. Let's load up Q5 again, but this time let's imagine that the spikes need to change. For the deck winch, our offstage spike that we previously defined needs to move a little bit. So we roll up to our spikes area in the editing panel, and let's change our offstage to be instead of 0, let's make it 12. Now, as you might have noticed, as soon as I pressed in 12 and hit the tab key to accept it, the spike here moved from the end of the track 12 inches in. Let's do something similar for our turntable. It's supposed to be going to position halfway, but instead of halfway being 180, let's make it 175. And maybe for the elevator, down will now be 6 inches up from the floor, so it doesn't go all the way to the floor. If we load up Q5 now and run it, you'll see that our deck winch should stop at 12 inches, our turntable stopped at 175, and the elevator stopped at 6. Fantastic. You can see how handy this will be in shows where you have lots of cues that maybe reuse the same positions over and over again. You can now use spikes to make labeled positions, and if those change at some future date during the tech process, you can easily edit them in one place and your whole show updates automatically. No longer will you have to track target changes throughout your entire show. Alright, well that wraps up our look at basic cue writing. In our advanced cue writing session, we'll take a look at cue linking and then also using the preview mode to graphically create cues. So stay tuned for more tutorials on Spikemark.